All right, this is a continuation of uh, the last video, Unit 5, Lesson 4. We're going to continue with problem 4.2 here. We're going to use all of this table, this information that we gathered in this table, and we're going to try and make sense of it algebraically. So we go to the next page here, number 5, and number 5 wants us to write an expression for the area of a rectangle with length L and width W. Well, that seems pretty straightforward. Well, I know the area is equal to the length L times the width W. Perfect. Now, what we want to do is we want to imagine the rectangle with length L and width W, and we want to dilate it by scale factor of K. So let's first take a look. Here's kind of what our original rectangle looks. Okay, and now we're going to dilate this, and let's suppose K is greater than 1, so that means that our rectangle is getting bigger. Now, how much bigger? Well, the length is getting K times whatever the original length was, and our width is now K times whatever the original width was. So here we have our new dimensions, and we want to write, oh boy, we want to we want to write an expression for the area of this new rectangle. Well, it's still going to be an area, but now we take this entire length, which is K times the length, and we multiply it by this entire width, which is now K times the width. Okay, so that's what the dimensions of the dilated rectangle. Okay, these dimensions, I guess I got ahead of myself. These dimensions, there's the dimension for the width, and there's the dimension for the length. And writing an expression, there's our expression for the area. It's K times the length times K times the width. Okay, now we want to use our work to draw a conclusion about what happens to the area of a rectangle when it's dilated by a scale factor of K. So in order to do this one, what I want you to do is I want to think about some multiplication facts here. If I take 2 times 3 times 4, that's 6 times 4, or 24. Couldn't I also write this as 2 times 4 times 3, which is 8 times 3, which is also 24. And I could further write this as 3 times 4 times 2, which is 12 times 2, still 24. So notice it doesn't matter the order in which these values are written when we multiply them. So if I take my area, which is just K times the length times K times the width, I can rewrite that as K times K times the length times the width. Now notice I threw those parentheses in there just because I want to remember that the length times the width at the top here is my original area. But now look what I have. I have K times K, which is K squared, times the length times the width. So think about what we did in our table in the last video, and notice we just took this K value, this scale factor that was in this column on the left. We took that scale factor, we squared it, and then that was how much bigger my area was getting. So my area started at 2, for example. So my area starts at 2, or my scale factor starts at 2. If my area started at 10, notice it was just 2 squared times 10 to get me to this 40. So that's why this algebra is working the way it's working. So that's pretty much it for this video. What we've done is we've just taken all of this concrete data that we gathered in the last video, and we've shown that it works algebraically no matter the dimensions or the scale factor that you have.